In this video, we're going to briefly talk about how to draw Lewis structures for simple organic compounds. Now, we're going to be building off of the concepts that we learned so far on how to draw Lewis structures for molecules. And this is because all of the organic molecules that are going to be discussed in this course follow the octet rule. Now, this is a gentle reminder that carbon can only form 4 bonds because it's in group 14, so has 4 valence electrons. Now, hydrogen also can form only 1 bond, and we discussed previously that is going to be a terminal atom. Now, when we're talking about these organic structures, we can note that some of the atoms in the organic structures can form multiple bonds. So for example, carbon can form double or triple bonds, nitrogen can form triple bonds, and then oxygen can form double bonds. Now, also when drawing Lewis structures, we have to be mindful that we have to account first for the single bonds and the lone pairs, and then we start forming the double or the triple bonds. Now, this is a very brief outline on how to draw these simple organic structures. We're going to first start by connecting all the non-hydrogen atoms. So for example, we're going to connect the carbon first, and then we're going to connect any other element other than hydrogen. So for example, if we have something like halogens like chlorine or bromine or oxygen or nitrogen, etc. Now we're also going to fill next the octet for the carbons with hydrogens, and then we will also, if there are any remaining valence electrons, we're going to try to fill in the octet of the terminal atoms. For example, if you have oxygen or nitrogen, you're going to complete their octets, and then if there are any electrons, valence electrons left, we're going to use them to fill in, to add double or triple bonds to fill in the octets, and usually these are for the carbons. And let's start with a simple example right here. So this molecule right here, this is, you're not required to know the name, but it is called acetaldehyde. Okay, and acetaldehyde has this structure right here. And sometimes, especially in this course with these complex structures, the skeletal and Lewis structure will be written out or drawn out as the formula is written. Okay, so in this case, I can write out the structure. So I'll start with the carbons, all right, and the oxygen laid out, okay, and then I will use the hydrogens to complete the octet of the carbon. Now we forgot to, or I forgot to, count out the number of valence electrons. So we can say number of valence electrons equals to 2 times carbon plus 4 times hydrogen plus 1 times oxygen. So this can give me 2 times 4 plus 4 times 1 plus 1 times 6. So I'm just multiplying by the number of valence electrons. I have here 8 plus 4 plus 6, which gives me 18 electrons, 18 valence electrons. Now, going back to the structure, I laid out the skeletal structure. The only thing I'm missing right here, and you can note from the way it's written out, that the hydrogen is connected to the carbon and not the oxygen. I get this question very often, and if you try to connect it to the oxygen right here, you will not get the correct number of valence electrons. You can feel free to try it on your own time to just get an idea on how to identify where the hydrogens are connected. And then I'm going to add the bonds. So I have 1, 2, 3, 4, 5, 6. So now I have 12 electrons, all right, 2 electrons per bond. So I have 6 electrons left, and these 6 electrons will be used to fill the octet of the oxygen because it's terminal. Now, note that the octet for this carbon is for fulfilled because we have 1, 2, 3, 4 bonds, but this carbon right here has only 1, 2, 3. So as we did before, the oxygen is going to donate a lone pair, and this is going to be the new Lewis structure of, sorry, this is a random dot. So this is going to be the new Lewis structure. And let's count out the total number of electrons: 2, 4, 6, 8, 10, 12, 14, 16, and 18. So this must be the correct Lewis structure. Now, I encourage you to try this on your own. It's the only way to overcome the challenge on how to draw these structures is just by practicing. And I'm going to start actually with choice B. So for B, because it's a more complex one, I'm going to lay out, or actually I'm going to start by counting the number of valence electrons. And the number for valence electrons right here is going to be, now how many hydrogens do we have? We have 1, 2, 3, 4, and 5. 5 times hydrogen plus 1 oxygen plus 1, 2, 3, 4, 5 carbons. Okay, plus 1 chlorine. Okay, so we have here 5 times 1 plus 1 times 6 plus 5 times 4 plus 1 times 7. And I'm doing this in real time with you. I'm not calculating it, or I haven't worked it out yet. Plus 20 plus 7. So right here I get 38 valence electrons. Okay, so we determined the number of valence electrons, and then I'm going to start by building up the skeletal structure. So I will first start by laying out the carbons: 1, 2, 3, 4, and then 5. And then I'll start by laying out the non-carbon atoms: oxygen, and then chlorine right here. Oh, it's, sorry, this seems like a carbon. So I'm going to say Cl, okay? And then I'm going to start laying out the hydrogen. So we note here that there is a hydrogen connected to the oxygen, okay? Because if we try to fulfill the, to add the hydrogen here, it's not going to be the correct Lewis structure, or not going to give us the correct number of valence electrons. All right, and then I'm going to have here H and H. All right, and then we have here H and H. And now I'm going to start by adding single bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So let's count how many electrons did we use up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So 38 minus 22 is going to be 16. Minus 22 electrons is going to give me 16 electrons. Now, these 16 electrons, we're going to use them to, or use some of them to fulfill the octet of the terminal atoms. So namely, the chlorine and the oxygen. So I'm going to have here 2, 4, 6, 8, and then 10. So minus 10 electrons. Now I have 6 electrons remaining. Now, this 6 electrons, since every octet is complete, we need to check on the octet of the carbons. Now, the carbon right here is happy because 1, 2, 3, 4. Now, this carbon, this carbon right here has only 2. So in this case, I'm going to add 1 and then 2. Okay, so it's going to be here a double bond. And then now let's count. So we have here 1, 2, 3, 4. So I think this is happy. So is this carbon now. Now let's look at these two carbons right here. Now this carbon right here has, and before that, I already utilized 4 electrons. So I have 2 electrons remaining, and these 2 electrons are going to go in there right here. So minus 2 electrons. Now I've finished all my valence electrons. Now let's count again. So it becomes 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. So that must be the correct structure. Now let's draw out the simple one. The simple one, you already know it as ethanoic or acetic acid because it comes from the acetate ion. And we're going to do the same thing. We're just going to write out the number of valence electrons. And the number of valence electrons is going to be 2 times carbon plus 4 times hydrogen plus 2 times oxygen. And it's going to give me 2 times 4 plus 4 times 1 plus 2 times 6. And it's going to give me 8 plus 4 plus 12. And this is going to give me 24 valence electrons. Now we're going to lay out our carbons, okay? And then the oxygen right here, there are actually 2 oxygens attached to the carbon, not the oxygens attached to each other. If you try drawing it that way, you will not end up getting the correct number of valence electrons. All right, so it has here and here and here. Okay, so I'm filling in. And note that the hydrogen at the terminal, I forgot to mention, it from the structure, from the formula, it is attached to the oxygen and not attached to the carbon. And now I'm going to fill in the bonds, 1, 2, 3, 4, 5, 6, 7. So 2, 4, 6, 8, 10, 12, 14. So minus 14 is going to give me 10 electrons. And then that will use these 10 electrons to complete the octet of the oxygen. So it's going to be 2, 4, 6, 8, and then 10. And so in this case, I don't have any valence electrons remaining. And let's look at the carbons and let's see if their octets are complete. So this octet here is complete. How about this one? This is not. So what's going to happen is 1 oxygen is going to donate its lone pair, and it's going to give me CH3 C double bond O. Okay, now let's check if we're going to get 24 valence electrons. 2, 4, 6. Oh, forgot here one. Let's count them again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So this must be the correct Lewis structure.